So in the earlier video, I showed you some pictures taken by James Webb Space Telescope. So in this video, I will explain those pictures and some others. So let's start with these two pictures. With giant storm, powerful wind, auroras and extreme temperature and pressure condition, Jupiter had lot going on. Now NASA's James Webb Space Telescope has captured new images of the planet. Webb's Jupiter observation will give the scientists even more clues to Jupiter's inner life. The two images come from the observatory's near-infrared camera, IR-CAM, which has three specialized infrared filters that showcase details of the planet. Since infrared light is visible to human eye, the light has been mapped into visible spectrums. Generally, the longest wavelengths appear redder and the shortest wavelength shows as more blue. Scientists collaborated with citizen scientist George Smith to translate the Webb data into images. In a wide field view, James sees Jupiter with its faint ripples, which are 1,000,000 times fainter than the planet, and two tiny moons called Amanthea and Adrastea. The fuzzy spots in the lower background are likely galaxies called photobombing, the Jordan view. Data from telescope like Webb doesn't arrive on Earth nearly packaged. Instead, it contains information about the brightness of the light on Webb's detectors. The information arrives at the Space Science Institute, also known as STSCI, Webb Mission Science Operation System as raw data. The STSCI processes the data into calibrated file from scientific analysis and it delivers to the Minkowski Achieve for Space Telescope for determination. NASA's James Webb Space Telescope has captured the first clear evidence for carbon dioxide in the atmosphere of a planet outside the solar system. This observation of a gas giant planet orbiting a sun like star 700 light-years away provide important insights into composition and formation of the planet. The finding accepted for publication in Nature offers evidence that in the future we may be able to detect and measure carbon dioxide in the thinner atmosphere of smaller rocky planets. Webb's 39b is a hot gas giant with a mass roughly 1/4 that of Jupiter, about the same as Saturn, and a diameter 1.3 times greater than Jupiter. Its extreme puffiness is related in part to its high temperature, about 1600 degrees Fahrenheit or 900 degrees Celsius. Unlike the cooler, more compact gas giants in our solar system, Webb's 39b orbits very close to its star, only about 1/8 the distance between the Sun and Mercury, completing one circuit in just over 4 Earth days. The planet's discovery, reported in 2011, was made based on ground-based detection of subtle periodic dimming of light from its hot star as the planet transits or passes in front of the star. Researchers traced light that was emitted by the bright white elliptical galaxy on the left through the spiral galaxy at right. As a result, they were available to identify the effects of interstellar dust in the spiral galaxy. Webb's near-infrared data also shows us the galaxy's longer, extremely dust spiral arms in far more detail, giving them an appearance of overlapping with the center bulge of the bright white elliptical galaxy on the left. Though the pair are not interacting. In this image, green, yellow and red were assigned to Webb's near-infrared data taken in 0.9, 1.5 and 3.56 microns. Blue was assigned to two Hubble filters, ultraviolet data taken in 0.34 microns and visible light in 0.61 microns. Webb's near-infrared data also shows us the galaxy's longer, extremely dust spiral arms in far more detail, giving the arms an appearance of overlapping with the center bulge of the bright white elliptical galaxy on the left. Although the two foreground galaxies are relatively close astronomically speaking, they are not actively interacting. VV191 is the latest addition to a small number of galaxies that help researchers at NASA directly compare the properties of galactic dust. This target was selected from nearly 2,000 superimposed galaxies pairs identified by Galaxy Zoo citizen science volunteers. Understanding where dust is present in galaxies is important because dust changes the brightness and colors that appear in images of galaxies. Dust grains are partially responsible for the formation of new stars and planets. So we are always seeking to identify their presence for future studies. Thousands of years never before, seeing young stars spotted in a stellar nursery called 30 Dorothas, captured by NASA's James Webb Space Telescope, nicknamed the Tarantula Nebula for appearance of its dusty filaments in previous telescope images. The nebula has long been a favorite for astronomers studying star formation. In addition to young stars, Webb reveals distant background galaxies as well as the detailed structure and composition of the nebula gas and dust. At only 1,61,000 light years away in the large Magellanic Cloud galaxy, the Tarantula Nebula is the largest and brightest star-forming region in the local group. The galaxy is nearest our Milky Way. It is home to the hottest, most massive star nodes. Astronomers focus 3 of Webb's high-resolution infrared instruments on the Tarantula, viewed with the Webb's near-infrared camera, INR camera. The region resembles a burrowing tarantula's home. Lined with its silk, the nebula's cavity centered in the INR cam image has been hollowed out by blistering radiation from a cluster of massive young stars. It sparkles pale blue in this image. Only the densest surrounding areas of the nebula resist erosion by these stars' powerful stellar wind, forming pillars that appear to point back towards the cluster. These pillars contain forming protostars which will eventually emerge from their dusty cocoons and take their turn sharpening the nebula. Neptune has fascinated researchers since its discovery in 1846. located 30 times farther from the Sun than Earth. Neptune's orbit in the remote dark region of outer solar system at extreme distance. The Sun is so small and faint that high noon on Neptune is similar to a dim twilight on Earth. This planet is characterized as an ice giant due to the chemical makeup of its interior. Compared to the gas giant Jupiter and Saturn, Neptune is much richer in elements heavier than hydrogen and helium. This is really apparent in Neptune's signature blue appearance in Hubble Space Telescope. Images at visible wavelengths caused by a small amounts of gaseous methane. Webb's near-infrared camera INR images objects in the near-infrared image range from 0.6 to 5 microns, so Neptune does not appear blue to Webb. In fact, the methane gas is so strongly absorbed red and infrared light that the planet is quite dark as these near-infrared wavelengths expect where high altitude clouds are present. Such methane ice clouds are prominent as bright stick and spots which reflect sunlight before it is absorbed by methane gas. Images from other observatories including the Hubble Space Telescope and the WMNEC Observatory have recorded this rapidly evolving cloud feature over the years. More subtly, a thin line of brightness circling the planet's equator would be a visual signature of global atmospheric circular that powers Neptune's wind and storms. The atmosphere descends and warms at the equator and thus glows at infrared wavelength more than the surrounding cooler gases. Neptune's 164-year orbit means its north pole at the top of this image is just an out of view for astronomers, but the Webb image hints at an intriguing brightness in that area. A previously known vortex at the southern pole is evident in Webb's view, but for its first time, Webb has revealed a continuous band of high-altitude clouds surrounding it. Webb also captured 7 of Neptune's 14 moons. Dominating this Webb portrait of Neptune is a very bright point of light spotting the signature diffraction spike seen in many of Webb's images. But this is not a star, rather this is Neptune's large and unusual moon Triton. On September 21, 2022, the James Webb Space Telescope delivered the clearest view of Neptune's rings in more than 30 years. Webb's near-infrared camera INR captured several bright narrow rings as well as the planet-fainter dust bands. Voyager 2 was the last to detect some of these rings during its flyby in 1989. But this is the first time we have an infrared image of them. Since INR images objects in the near-infrared range from 0.6 to 5 microns, Neptune does not appear blue to Webb. In fact, the methane gas so strongly absorbs red and infrared light that the planet is quite dark at these near-infrared wavelengths, except where high-altitude clouds are present. Those methane ice clouds are prominent as bright as stick and spots which reflects sunlight before it is absorbed by methane gas. Two of NASA's great observatories, the James Webb Space Telescope and the Hubble Space Telescope, have captured views of a unique NASA experiment to intentionally smash a spacecraft into a small asteroid in the world's first ever in-space test for planetary defense. These observations of NASA's double asteroid redirection test impact mark the first time that Webb and Hubble simultaneously observed the same celestial target. On September 27, 2022, at 4:44 Indian time, DART intentionally crashed into Dimorphos, the asteroid moonlet in the double asteroid system of Dynamos. It was the world's first case of kinetic impact in mitigation technique using a spacecraft to deflect an asteroid that poses no threat to Earth and modifying the object's orbit. DART is the test for defending Earth against potential asteroid or comet hazards. The coordinated Hubble and Webb observations are more than just an optional milestone for each telescope. They are also key science questions relating to the makeup and history of our solar system, and that researchers can explore when combining their capabilities of their observatories. Webb and Hubble shows what we have always known to be true at NASA. We learn more when we work together, said NASA's Administrator Bill Nelson. For the first time, Webb and Hubble have simultaneously captured imagery from the same target in the cosmos, an asteroid that was impacted by a spacecraft after 7 million mile journey. All of humanity eagerly awaits the discovery to come from Webb, Hubble and our ground-based telescopes about the DART mission and beyond. If you enjoyed this video, you will enjoy this one where I explain what is the James Webb Space Telescope. Till then, I will meet you in the next video. Bye.